Arrays of objects. The elements of an array can be object references. The following declaration reserves space to store 5 references to string objects. And here's the declaration they used. It does not create string objects themselves. Initially, an array object holds no references. Each object stored in the array must be instantiated separately. The words array were initially declared. They declared words and it could hold 5 strings, but it doesn't really point to anything because those values are currently null. At this point, the following line of code would throw a null pointer exception. System.println words, and actually it would not throw a null pointer exception after some string objects are created and stored in the array. So here they're showing this is what it looks like. So here's the words array. It's holding references to objects. So words array actually points to a reference, and that reference points to the string object. So they have 3 strings inside of this array. Keep in mind, string objects can be created using literals. The following declaration creates an array object called verbs and fills it with 4 string objects created using string literals. So here they have an initializer list and they pass in 5 strings: play, work, eat, sleep, and run. And that's what they assign to the array verbs. Let's go ahead and hop into a demo where we use string objects and arrays. I created a new project called Array of Strings Demo, and in here I went ahead and set up my main method, and in my main method I declared an array that can hold 5 strings. So let's go ahead and output the values that are in this array. Now remember, I haven't actually put any string objects into this array, so we're expecting the values to be null. So I'm using a for each loop to output the values. So here's my name array, and I'm basically just iterating through this list, and I'm putting each item in this list into a string variable, and I'm printing it out. Let's go ahead and run this program, and here's my output. As you can see, system.println just simply prints out null. So the null pointer exception will only get thrown if you try to invoke a method on this string. So this is already null. So if you try to invoke something like length or trim or some method that you can invoke on a string, then that's when you'll get the null pointer exception. So the only way for us to get a null pointer exception is if we were to invoke a method on this string right here. So typically when we have a string object, we have a whole slew of methods available to us. So one of those methods is length. So let's go ahead and invoke the length method on each one of these objects in this array. I'll run this program. As you can see, I get the null pointer exception. So I'm trying to invoke a length on this string, but there's nothing there. So this reference points to nothing in memory. So I get my null pointer exception whenever I invoke this method. But if I were to set these values, then this would be okay. So I'm going to go ahead and set these values. So here I'm setting the values of my array. So now when I invoke a length, I will not get a null pointer exception. So here's me running the program. Each one of these strings has a defined length. So the first string had 3, next one 4, 5, 6, and 7. And here are my strings. So like what we did for the integers, we can also set this up by using an initializer list. So I'm going to go ahead and do that. And here's my initializer list of strings. So I'm doing everything pretty much the same. So before I declared my string object and then I filled each item. But now what I'm doing is I'm simply just making an initializer list and I'm taking those values of strings as an initializer list. So now when I print this out, I should expect the same results. So I'm going to go ahead and run this program, and here are my results. Exactly the same as I had before. The following example creates an array of grade objects, each with a string representation and a numeric lower bound. The letter grades include plus and minus designations, so must be stored as a string instead of a char. See grade range and grade. So they created a class called grade. It has a string for name and an integer for lower bound. Here's the constructor. They pass in the grade and the cutoff, and they set their instance data. They have a toString, setters for the name and lower bound, and getter for the name and lower bound. And that's all they have in their class. So here's a driver class. They have an array for grades. They're using an initializer list designated by these curly braces here. Then they have their data comma separated. Now they're using constructors to instantiate their objects. So they're passing in constructors into the initializer list separated by commas. So they have each type of grade, the A minus, B plus, B, and so on. Now if you ask me, instead of making a class for grade, I think it would have been better just to make an enumeration because there's a finite set of values. But anyways, the book went ahead and used their class and created this array. And they just print out each type of grade, and here's what the output looks like. Now the reason why I wanted to use an enumeration is because wherever they use this grade, these are all the possible values. There'll never be anything else. So to me, this should be a list of constant objects, which would have been easier just to use an enumeration to do it. Now let's look at an example that manages a collection of DVD objects. An initial capacity of 100 is created for the collection. If more room is needed, a private method is used to create a larger array and transfer the current DVDs. See movies.java, DVD collection.java, DVD.java. So let's start off by looking at the DVD class. So here's all the instance data for the DVD. They have the title, director, year, cost, and a boolean indicating if it's a Blu-ray or not. Here's their constructor. Their constructor takes in all that information and sets the values for the instance data. And then they just have a toString. So they actually don't have any getters and setters for the instance data. That's fine. That's that's the way the developers decided to do it. So what the developers are doing is, since they don't have getters and setters, the only time we set our data is through the constructor, and it's never going to change. And the only way to get the data out is by calling this toString method. Then they have a class called DVD collection. DVD collection has an array named collections that hold DVD objects. They have a count and they have a total cost. So when you first create your DVD collection object, here's a constructor. They're setting the array to size 100. So the count is going to keep track of the number of DVDs that get added to this collection. And then they have the total cost equal to 0, because as the DVD is added, the total cost is going to go up. Then they have a method called add DVD that takes in all the same parameters as a DVD constructor takes. And they're saying if the count is equal to the collection length, this means that you ever get to 100, they're going to increase the size. So it starts off at 100, but as you add more DVDs, you're going to increase the size. Then what they do, they create a DVD object with the information passed into this add DVD method, and they instantiate their object here, and they add it to the collection. They get the cost of the DVD and add it to the total cost, and they increment their count. Here's their toString. Their toString is just printing out all the information, and here's their increase size. So this is the method they're calling whenever they need to increase the size of their collection. So they're getting the collection length and multiplying it by 2 and creating a new array that holds DVDs, and they're transferring over all the DVDs into this array, and then they're setting the collection equal to temp. So now collection points to this object in memory. So they're basically abandoning their old array and creating a new one that can hold more DVDs. So this is essentially how the array list class works under the hood. It basically does all the size managing for you, but in this class they're doing it on their own. And here's a driver class. So what they're doing in their driver class, they instantiate a DVD collection and they add movies to it, and they're printing out the movies. Pretty simple stuff. Here's the output. So here's a UML diagram of the program that we just saw in the lecture slides. Here's the driver class. The driver class uses a DVD collection. Their DVD collection uses a DVD object. Command line arguments. The signature of the main method indicates it takes an array of string objects as a parameter. These values come from command line arguments that are provided when the interpreter is invoked. For example, the following invocation of the interpreter passes 3 string objects into the main method of the state eval program. So here they're calling Java, and here's the program, and then they're passing in Pennsylvania, Texas, and Arizona. See name tag.java. So here what they're doing is they're using the array that's being passed into the main method, and they're grabbing the first item at index 0 and the second item at index 1. And here's what the output looks like. So I made a new project called command line arguments demo. I'm going to go ahead and demonstrate passing command line arguments to a program. So we always use this header for the main method, but we never really talked about what's being passed into the main method. If you look, the main method accepts an array of string types. So args is actually an array. So if we wanted to know the size of this, we can just do a system out print line and print out the length of that array. And here's me printing out the length of the array. I'm going to go ahead and run this. And as you can see, the length of the arguments being passed in is 0. And that's because I ran this program without passing in any values to it. Now, if I wanted to iterate over this array and print out each value, I can do that using the for each loop. And here's me using the for each loop to print out each value of the array. Again, the array comes in as empty, so this is really not going to do anything, but I'm going to go ahead and run this program anyway. And I got the same results. So the for each loop didn't actually execute anything because there's nothing inside of that array. And the reason why I have no data coming into this program is because I never pass any data into this program. So whenever we run a program, we have to pass in arguments if you want to see arguments inside of our program. Now, because we're using IntelliJ, we're not actually using command prompt to run this program. So if we wanted to pass in arguments into this program using IntelliJ, we go to run, then go down to edit configurations, and here you'll see program arguments. So then you can just type out a list of arguments. It can be numbers, it can be letters, it can just be words. Now normally we just ignore arguments, but you can actually write your program to listen for specific types of arguments. So I'm going to go ahead and type in some values in here, and here are the values that I passed in. So your arguments are delimited by space. So this can be tokenized by space. So that means the first argument is 1, the second one is 2, then 3, and then test is 4, dog is 5, and so on. So I'm going to hit apply and OK. I'm going to go ahead and run this program again, and now you can see that my args list is 7, and here are the arguments that I passed in. Now typically this is used whenever you want to go into your program in a certain mode, like just say if you ever want to run your program into debug mode or just print out more information, you can listen for an argument coming into the program. If I wanted to do the same thing but do it through command prompt, I can open up command prompt, go to this folder, and run this program with Java. So a quick way to open command prompt in a folder is you go to the folder where you want to open your command prompt. So this is where I want to open my command prompt. This is a Java file that I want to test. Just come up to your locations bar and just click inside of here and type CMD. Press enter and it opens command prompt in this location. Now from here I can compile and run my program. That's me compiling. Here's the command to run the program. As you can see, I didn't pass any command line arguments to it, and then run the program again, but this time pass in command line arguments by using space and then type in whatever you want after you enter the name of your program. And here's my output.